Today we're going to start the new Math Module 3, and we're going to be going back to multiplication and division. Okay? So we're going to begin studying commutativity to find the known facts of 6, 7, 8, and 9. Have we done 6, 7, 8, and 9 yet?
No. I know some.
You know some of them, but we haven't done some of them yet, right? Okay. So, let me ask you this. What does this word mean? Commutative. I think you've heard it that way more frequently. Commutative, Kaden. What does that mean?
It means that you can do skip count and you can do problems. Division problems.
Not division problems, Lonnie.
You shift the problems around.
You switch the factors in the problem around. What type of problem, Jazarin?
A multiplication problem.
You flip the factors in the multiplication problem around, right? So the factors are the two numbers that you're multiplying. One is going to represent what? Jazira? One's going to represent equal parts. What's the other one going to represent, Harmony? Groups. Okay. What does the answer to a multiplication problem, what do we call that? Carlasia? It is a total. What's another way that we can say it, Evan?
Product.
The product, okay? So we're going to be looking for the groups, equal parts, and the product again, but we're going to be talking mainly about the commutative property today, okay? So just like when we are doing our work in the morning time, we do our morning work and we do our arrays, you always flip your factors, don't you? You do your multiplication problem both ways. So we're going to be putting that to use today. Now, I have it written in unit form, and I want you to turn it back into a multiplication problem. This is going to help us because on our problem set, they're going to have some of the problems written in multiplication problems, and some are going to be written in unit form, okay? So I want you to be able to tell both ways. All right. 4 sevens. Ashanti. 4 times 7. Beautiful. 8 nines. Jazira. Mike, I need to get your seat.
8 times 9.
Yes, 8 times 9. 6 threes. Carlasia.
6 times 3.
Good. 3 twos, Myasia.
8 times 2.
Good. 6 fours, Harmony.
6 times 4.
Good. 9 fives, Demarian.
1 times 5.
Good. 8 threes, Michaela.
8 times 3.
Good. 5 threes, Micah.
3 times.
Say it in a multiplication problem. Good. 3 eights, Hannah.
3 times 8.
7 twos, Lonnie.
7 times 2.
Good. 4 fives, Jazira.
4 times 5.
9 fours, Brenna.
9 times 4.
Okay, so we did that, but now what if I asked you to show me the commutative property in unit form? What if I said 4 sevens? How could I use the commutative property but say it in unit form, Jazira?
7 4.
Oh gosh, okay. I thought I was going to get y'all with that. 8 nines, Lonnie.
9 8.
Okay. 6 threes, Kaden.
3 6.
Oh, good job. 3 problem today. And Ms. Darby wants to make sure that we have a criteria for success on completing it correctly because we want to have strong work in here, right? Let's remember what's needed to successfully complete a word problem. Who can tell me the first thing you have to do when you complete a word problem? Harmony?
Read it.
You have to read it. Of course. So I agree with you. Who can tell me the second thing you need to do, Hannah?
You need to rewrite the sentence.
Is there anything else that we do before we rewrite? Think about that.
Underline.
We underline. And also, we're going to label, right? Now, what do we do next, Ashanti?
It's not Monday.
You should know it. What do we do next?
Then we, sentence.
We write a sentence. We restate our question into an answer statement, but we leave the answer blank because we don't know the answer yet, right? This helps us to understand what we are actually trying to solve in our problem. So what comes after we do that, Jazira? We have to draw. We have to draw something. And do we get to choose what we're going to draw?
No.
Yes.
Yes, unless it tells us, right, Lonnie? Unless it tells us draw a tape diagram or draw an array or draw a scattered picture. If it doesn't tell us, we can choose whatever we are the most comfortable with. There are a bunch of different ways. Ashanti?
What is a scattered picture?
That's whenever we would draw like circles, and then we would put how many in each. Yeah.
Like the stars.
Okay. So what comes after the drawing? Kaden?
The number sentence.
The number sentence. Awesome, Kaden. That could be a multiplication, that could be addition, subtraction, division, whatever the word problem wants us to do, right? And what's the last thing, Evan, that we need to do?
Run word sentence? No.
We have to finish our word sentence,
Yeah,
right?
fill in the
Because
blank.
we wrote it, all we have to do now is fill in the blank. Very, very good. So, Ms. Darby wants you to remember all these things as you're working your application problem today. Okay? Please get out your math module book and turn to page 4. I'm going to give you about 5 minutes and I want you to complete it. Ms. Darby put our criteria for success over here so you can check and make sure you've done all of the steps. Jerry brings 3 water jugs to her soccer game and she's going to share it with her teammates, okay? Each jug contains 6 liters of water. How many liters of water does Jerry bring? I'm going to give you 5 minutes to complete this problem. Jaziran's going to be our teacher for this problem. There's more to come, so don't get upset.
What do I have to underline first? Relation. Jerry brings 3 water.
Do you think Jerry brings, do you think that would be very important, or do you think we could just condense that, we could shorten it down? You want to shorten it down? Okay. So what exactly do you want to underline? Okay, 3 water jugs. Good. Oh, Ben, I got you on the thing. Okay.
So we're a soccer game to share with her teammates. What do I have to underline next? One. Each jug contains 6 liters.
Very good. So each, remember, is our key word, one of our key words for equal parts when we're doing multiplication, okay? Don't pick your heads up if they're down. You need to be having your heads up and focusing.
What do I label first? Shante? Label 3 water jugs.
Okay?
Label it to the group.
Very good, Ashanti.
What does the six represent? What am I missing? Jesus, the total. Total equals.
What's the total going to equal?
Harmon? Total is going to equal to 18. Well, no. Wait, right now, since we don't know the total.
Question mark. Good. But the total does equal to 18 in the long run, right? Okay.
What picture should I draw? Jesus?
errors and he changed it. But, so while Josiren is drawing that, he's gonna take, he wants you to do a tape diagram. Oh. While Josiren's drawing that, does it matter if you do a number bond or a tape diagram or an array or a scattered picture on this one? Why? Lonnie?
This is say what we're supposed to do.
It doesn't tell us what we have to draw, so we get to choose on this one, right?
How many lines would I draw inside of here? The 0? 2. I would draw 2 because when we have a tape diagram, we would have to draw 2 lines, and it will still be 3 groups. How many go in each? How many? 8. What? 6.
Good. It's okay.
Now let's go here and see if I got everything. Did I read the problem?
Yes.
Did I underline what is important and later?
Yes.
Did I restate the question?
No.
Oh my, well, that's why our checklist helps us, right? All right, then go ahead, let's restate it.
What will be my question? Statement. Brenda?
Jerry brings
Don't tell me the total minute.
Jerry brings blank water jugs for his teammates. G.
Yeah, go girl. Uh-huh. Good. It's hard. It's hard. Don't do that to yourself. You're wrong, because it is. Here. You got it all here.
Blank. What?
This is your sentence, baby.
My sentence says
Jerry.
Jerry brings blank liters of water. Mine.
Oh, yeah,
That's how many liters of water?
Yeah, because the question is, Brenda, because the question is how many liters of water does whoever bring
Jerry, baby.
bring, and you said Jerry brings blank jugs of water. That's true.
So you want to make sure you
But the
completely
question
restate. Okay. So go ahead and finish it. Jerry brings blank
Liters of water.
liters of water. Okay. Okay. So we've restated. What's next, Josiren?
Have we completed a drawing?
Yes.
No. The number sentence.
No.
What would be my number
I
sentence?
did. I did.
What am I?
My agent.
You're gonna call me about 2 times.
Okay.
3 times 6.
I'm about to write 81.
That's okay. All right. So what's next now?
Have we finished our sentence?
Yes. No. We gotta put 18. What? You gotta flip it.
I'm not gonna
No, you don't have to.
You gotta put 18.
All right. Now are we finished?
Yes.
All right. Good job, Josiren.
Thank you all.
All right, let's hear Josiren a roller coaster into a firecracker, please. 1, 2, 3. Woo! Woo! Miss Darby's going to move you with your partner because I want you to be able to discuss some of these things with your partner, okay, as we're talking through the concept development today. So on number 1 on page 5, you have these 2 tape diagrams. And when you get with your partner, Miss Darby wants you to discuss which tape diagram represents the application problem, 3 times 6. And then I also want y'all to talk about how do you know that? What tells you that it represents that one, okay? So when Miss Darby's ready for you to come back and quiet down and stop talking to your partner, I'll do the signal shh, 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 and then you'll do it back, okay? That's okay. All right, movers stand. Movers move. She knows where she's going. Movers sit. All right, start discussing with your partner. Go. Oh, Evan, how do you know? Tell us how you know that. It can't be so. Because you want to use the vowel harmony that actually represented. You know Jesus? Which one? Just look at yours. Look at you drew. So it needs to look like yours because you drew one. Okay. Which one looks like yours? So why would we choose this one? There's 6 fruits on there. And we had 3 jugs of water, right? And then this is saying that there's 6 in each. Okay? So you want me to circle it? Oh, Lonnie and Jazira are writing a sentence. Who can tell me which one you would choose? Which one of these tape diagrams represents the problem we used in the application problem? Michaela?
The one that we used was the first one because there were 6 equal parts and 3 groups.
There's 6 in each, right? And there's only 3 groups in this tape diagram. 1, 2, 3. Okay? And then this is also representing the question mark for our total. We do not know the total yet, right? This one would be our commutative property, don't you think?
Yes.
So if we turned it, because what?
Because we split it, so they got six groups, and you have to put 3 in each.
Awesome, Ashanti, exactly. So if you go to number 2, they want us to write a multiplication problem now to represent this tape diagram, which y'all know it, and then a multiplication problem to represent this tape diagram. Please do that on number 2 right now. Well, I'm actually walking and I see almost everybody has it complete, so I'm going to give you about 20 seconds probably. Okay? Write a multiplication problem for each tape diagram. You already did it, baby.
You have to do the answer.
I would love for you to put the product on there.
This right there.
Oh, you got it backwards. That's what I'm trying to tell you.
Nope. How many groups are there? Okay, then we need you to work. Okay, who can tell me the multiplication problem that represents our first tape diagram? Carlasia. What? Oh, you told me the answer. Okay, 3 times 6 equals 18. Harmony. Tell me the multiplication problem that represents the second tape diagram.
6 times 3.
6 times 3. Great, baby. And that's also equal to what total?
18.
18. Good. 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 How are these 2 multiplication sentences related to one another? How are they related to one another? Brenda?
Because you're just switching them.
You're just switching what? It says the groups and equal parts. Hang on. Evan. You're switching the factors, but what's going to be the same, Lonnie? The product is still going to be the same. Even though we're switching the factors, right, Jazira? It doesn't matter. Our product's going to be the same. So you have this on number 3. So you should write that on number 3. Okay? That we're switching the factors. They're using the commutative property. We're just switching the two factors and the product's the same. So, this is an example of the commutative property that we learned about in Module 1. Miss Darby wants you to do 1B at the bottom, 1B at the bottom of that same page, number 2, so circle number 2, and then when you turn the page, I want you to look at 7, page 7, you're going to do 3A, D, H, and K, okay? A, D, H, and K. Miss Darby wants to go over G with you before you begin. So turn your page to page 7 and we're going to look at G really quickly before we begin. They say up there that 3 times 9 is equal to 10 threes. And then it says minus blank 3. So what they're wanting to do now is they're using a 10 fact and they're trying to subtract a 9, okay? And how many 9s would they need to subtract to get back to 9 threes? They need to subtract 1 3. So that's 30, right, minus 3. 30 minus 3 is what? Who knows the answer to that? Ashanti?
20.
I called on Ashanti.
27.
Yes, ma'am. Okay, so on some of them you need to be very careful because they might be asking you to subtract some. And then if you look down here, they're breaking them up. So they're decomposing like we do in the morning when we do our morning work, okay? So they're taking the 6 and they're breaking it, and you got to figure out how are they going to get back to 6. Okay, Miss Darby's going to give you 10 minutes to finish those because there's not that many. Go. Miss Darby, I have it back on the board, baby. So if you notice, we're just counting like 2, 3, 4, 5, 6. Is there another one? No, because it's at 2. So what's 2 times 7? That's going to be the answer down there. Because you have to look, it's 7 times 2. 7 times 3, that's the answer. 7 times 4, you got to put the answer there. 7 times 5. So what's 7 times 2? What's the answer? So 14 goes here. Hey guys, y'all see? Look. 2. You're going to just count by 1s going across this one. Tomorrow, I want to see you working and not doing what you're doing, please. So write your numbers. Okay, so now down there, no, it's 2 times 7. What's the answer to that? Okay. All right, let's flip this. 2 7s, raise your hand, harmony equals what? 7 2s, good. And that 7 times 2 is equal to 14 because they gave us that answer. 4 times blank equals 6 times 4. 4 times, Micah? Good. 4 times 6 equals 6 times 4, and 6 times 4 equals what, Micah?
What?
Good, baby. All right. 10 4s minus 1 4 equals how many 4s, Ashanti? Okay, Lonnie?
9 4.
9 fours or 9 times 4. And 9 times 4 equals what, my Asia? Good. Okay, this one we're putting it together and making one big fact. So 5 threes plus 2 threes equals what, Carlasia?
7.
7 times 3 or 7 threes. 7 times 3 equals what, Michaela?
7 times 3 equals 21.
Good. All right, guys. So, we are at the point where we're getting ready to do our exit ticket. If you turn your page, don't start yet, please. How did using the commutative property today help us solve more facts? Like when you were doing that number or multiplication chart, did you notice anything about using the commutative property, Hannah?
Well, it helped us a little bit because it was showing us how to switch problems that are multiplication, and we did two. So when we had the commutativity, it helped us a little bit more because it showed us what if we did the other one, it would equal the same thing.
Okay, so even though if it was 3 times 6, what she's saying is when you switch it, now you know a 6 fact, which is 6 times 3. Lonnie, did you have something? No? Okay. So I agree with that. Does anybody have anything else? Any other reason why it was helpful to us? Lonnie?
I agree because if it's going to equal the same total, it just flips around.
Okay, that's the perfect way to finish that out right there. He said, so if we knew 3 times 6 and we switch it at 6 times 3, it equals to the same total. So now we know 2 facts in 1. Please put your books down. I asked you not to start.
How?
Why don't you put your pencils in the cup? How did you find both of the multiplication facts in the array on problem 2? How did you find both of them? What did you do? Evan?
Counted.
He counted what?
The groups.
Okay, so you counted the groups and that gave you your
Answer.
your first, not your answer.
Factor.
It gave you your first factor. And then what did you do to get your second factor? Jazira?
Right here.
Yes, on problem 2.
Counted each row.
Okay, you counted how many was in each row and you got your second factor. Good. And that helps you get your total. Very good. Okay. What did you notice about on problem 3? 3A. Look at 3A. Okay? What did you notice on 3A about the words and numbers on each side of the equal sign? What way were the words and numbers written in? What way was that? Was it a multiplication sentence? What was it? Hannah?
It was showing you how to switch them.
It was using the commutative property. And wait, let me ask somebody else. What are you doing? Okay, but raise your hand in your seat. Brenna, and what else? How was it saying it? How was it written? It was written in uniform, which we did a lot of practice with, right? So today we learned about commutativity. We learned about the commutative property, right? We can switch our factors, and we can get the same product for both of those multiplication problems. So y'all did a great job. What I would love for you to do is do your exit ticket. I'm going to give you 5 minutes. Please self-assess, and when you're finished, turn it into the drop box and begin working on your homework.